Okay, so the instruments on the airplane, okay, uh, tell me that I'm flying relative to the air of 120, okay, and the direction of the relative velocity is 7 degrees east of north, okay? Instruments on the ground give me the velocity as 110 and its course at 60 degrees, okay? I want to find the wind speed, okay? So here's these relative velocity problems are actually pretty easy once you set them up. Setting them up is the hardest part. So the equation that I have here is the velocity of B equals the velocity of A plus the velocity of B relative to A. So let's start by talking about that velocity of B relative to A. And what that's actually saying is it is saying what is the velocity of the plane relative to the wind. Okay, so this is the velocity of the plane relative to the wind. Okay, that means that the velocity of B is the velocity of the plane, and the velocity of A then is the velocity of the wind. Okay, so essentially what this is saying is the velocity of the plane is the velocity of the wind plus the velocity of the plane relative to the wind. So from that, the velocity of the plane relative to the wind is what the people in the plane are seeing. So in the plane, it looks like you're flying at 120 kilometers per hour, okay, at 70 degrees east of north, okay? So in the x direction, then that would be sine of 60, I'm not sine of 60, sine of 70 plus 120 cosine of 70 in the j direction. That is what on the plane it looks like you're traveling, right? So relative to the wind, you're up in the plane. Okay, this is what it looks like to you. On the ground, we're getting the absolute velocity. That's what the velocity of the plane actually is right here, right? Which is going to be the velocity of the plane. You know, this is the total velocity of the plane seen from the ground. So that's going to be the 110 times the sine of 60 in the I direction. So that's what he's actually doing. That's this, you know, the course, okay, plus 110 cosine of 60 in the j. Therefore, the velocity of the wind is, again, the velocity of A, which is going to be the velocity of the plane minus the velocity of the plane relative to the wind. That's how we're going to figure out what the wind actually is, right? Knowing what the actual speed of the plane is and subtracting from that the speed of the plane relative to the wind, I'm just left with what the wind is, just kind of rearranging things I have there, right? Because VA is going to be VB minus VB with respect to A. So from that, I can find the velocity of the wind just by subtracting these two vectors. This is where it becomes pretty easy. Okay, so taking 120 sine of 70, okay, taking that and subtracting that from 110 sine 60, okay, I get negative 17.5 in the I direction. Do the same thing in the J direction. I get 13.96 in the J direction, just basically subtracting these two values from one another. That gives me the velocity of the wind. Okay, now taking the square root of the sum of the squares, I can rewrite this as 22.4, and that'll be kilometers per hour. And I can get the angle doing an inverse tangent. I'll let you do that on your own, and you can get it's 51.4 degrees. So that's the direction the wind is blowing. And that's why on the plane it looks like you're traveling one way, but on the ground a different way, because that wind is pushing you a little bit further. So the direction of that wind hopefully makes sense based on, you know, what we know about this problem. But again, the trickiest part here is getting the, you know, the A's and B's and planes and winds to kind of line up and make sense. Once you get that set up, then, you know, the mathematics of solving that equation is pretty easy. It's just a vector addition to solve it from there.